So we have a puddle, and currently this puddle has a volume of 500 milliliters, but it's evaporating at a rate of 4% per hour. That means we're losing water 4% of the amount per hour. It's diminishing. So we want to write an equation that represents how much water is left. So to do that, remember we have what is currently there equals the starting amount. Now we start with 100%, but we're decreasing. Just like the value of the car, the problem we did a while ago, we're decreasing. So decreasing is an example here of evaporating. We're going to take 100%, subtract 4%, which is 96%, written as a decimal. How often does it occur? Every hour. The next part of the problem says, let's determine how long will it take for the puddle to be reduced in half. So if it's 500 now, how much will it have when it's half of that? So 250 equals 500 times the quantity 0.96 raised to the, and any number divided by 1 is just that number. So I can just put an X. Divide by 500. 250 divided by 500 is 0.5. Remember, why do we learn logs? And the purpose of learning logs is without logs, you couldn't solve for a variable that's in the exponent position. So I'm going to take this number and write log of 0.96 on both sides. And then I'm going to write down what was already there. So the log of 0.96 and the 0.96 answer behind it, they cancel out, really turning it into a 1. And I bring down the x. How do I get this answer? This is called a change of base formula. You don't have to memorize it, the words of it, change of base formula. And to do that, it allows us to evaluate this. So to evaluate this portion, every single time you take log of whatever number is behind. So at this time, find the log key and type in log of 0.5 and press enter. Log 0.5 and press enter. And then you do log of the base and press enter. So it looks like this. Log 0.5, enter, divided by log, in this case of 0.96, enter. All right, well, let's round again. Let's round this time to the nearest hundredth. So this is 16.98. Approximately 16.98. And what does this represent? X is the time it takes for the puddle to reduce from 500 to half of that amount down to 250. And this was in terms of hours. So it is approximately it's nearly approximately 17 hours for the puddle to reduce to half its original volume. Talk to your partner, make sure they understand the math, and we'll go on. We have 2 left to do it in this packet. Please check with your partner at this time. Yeah. You don't, as long as you understand that it represents the time. 17, yep. But let's do 17 hours at least. Get the right units. Myra purchased $500 worth of stock in the Tennessee Technology Corporation in January of 2011. The value of the stock is expected to increase, so it's going up. So we're going up from 100%, right? Is everybody listening right now? Oh, you cannot see it. Thank you. We're going up. So we're increasing by 6.25% per year. When will the value of the stock, so when? They're saying what year? In what year will the value of the stock be expected to reach 1,200? Okay, so we start with a value of 500. That's the initial stock that you invest. And it's 1 plus We're going to write this percentage as a decimal. And how often does it increase? Per year. Whatever this number is, that's how often does this happen, goes up top, 1 times x. Okay, now we want to solve this and find out how many years, bless you, how many years will it take until we reach an amount of 1,200? How many years until we reach an amount of 1,200? So now I get to write 1,200 equals 500 times the quantity. Well, this divided by 1 is just this decimal, and if I add this decimal to 1, I get 1.0625. 1 times x is just x. Remember, the whole purpose of learning logs is so that you can solve for a variable in an exponent position. Divide by 500, please. And please tell me, what is 1,200 divided by 500? It should be a nice decimal, maybe 2 point. Okay, so 2.4 equals 1.0625 raised to the x. Now, to solve for x, I'm going to do the log of this number, whatever I'm trying to get rid of. Log of 1.0625 to both sides. Then I'll write down everything that already exists. And now I get to cancel out and bring down the x. How do I get this answer? It's called change of base. You don't have to memorize that title. Please right now do log of the back number, press enter, divided by log of the base. So log of 2.4, enter, divided by the log of 1.0625. I have approximately, before we make sense of it in this problem, approximately 4.4. Hands up high if you have the same on your calculator. Now, here we go. You ready? What does that mean? Give me the year in which you will reach $1,200. The stock will increase to $1,200. In what year? You may be saying, what is it? So during 2015, what you can do is take this amount plus the initial year. Does it mean it's at the beginning of 2015? Almost halfway through. Does everybody see where it's almost 0.5? So nearly halfway through the year 2015, nearly halfway through the year 2015, the stock will reach 1,200. Okay? Make sure you and your partner understand before I go on to the last problem. Please find problem 19. Christopher starts an experiment with 7,500 bacteria. This is your initial amount. After 4 hours, there are 23,000. Write in, and this is number 19 in the word problems. Write an equation that can model the number of bacteria after a specific number of hours. And how do we figure out the rate? That's the problem. So here we go. Remember, this is what we're looking at. This is our general equation. We're looking at an exponential function, general equation. So what we get to do is we go, all right, I know I start with 7,500. And I know I have 23,000 left after 4 hours. How does this allow me to solve for B? Well, let's first divide. Please take 23,000 divided by 7,500. And is it a nice decimal? You're telling me. No. It is not a nice decimal, okay? All right, so let's leave it as a fraction reduced. So let's leave it as reduced fraction, which is, do you have 46 over what, 15? Yes. 46 over 15 is reduced, equals b raised to the 4th. To get rid of this exponent, this is different than logs, I could just raise it to the reciprocal, 1/4. Now these cancel out and I have b by itself. Let's see what b is equal to. put this in parentheses and put this in parentheses. So it looks like this. 46 divided by 15 raised to the 1/4 in parentheses. So approximately, the more numbers we write, the more accurate. Let's see if it's a nice fraction. I don't think it will be. Oh, it is. Wonderful. Okay, this is our 12,209 over 9,226. That is our rate. That's the rate in which this bacteria increases per hour. So here's our equation. Y equals the initial amount times the rate raised to some hour. And now we're going to solve this for 12 hours. So take this rate and raise it to the 12th, get an answer, and then multiply by 7,500. Take this number, raise it to the 12th, and take it times that initial amount. And we have approximately 216,302 approximately cells, bacteria cells.